In this video, we will be doing 3 more examples from the chapter of surface areas of the cones. Okay, so this is exercise 11.1 from the textbook, and we are going to do question numbers 6, 7, and 8 from this exercise. Okay, let us do the first problem, which is question number 6 from the exercise 11.1. Okay, we are given the slant height of a conical tomb to be 25 meters and the base diameter is 14 meters. We are asked to find the cost of whitewashing or painting the curved surface of the conical tomb, given that the cost of painting 100 meter squares is rupees 210. So if the rate of painting, if the cost of painting per 100 meter square is 210 rupees, we have to find what is the total cost of painting the tomb. Okay, so the tomb is conical in structure. We are given the slant height as 25 meters. So let's write down what is given. So we have given the slant height L equals 25 meters. We are also given that the diameter D is 14 meters. So therefore, we can find the radius R, which is going to be half the diameter. So that's D by 2, which is going to be 14 by 2. So that's going to be 7 meters. Okay. So now that we have all the parameters of the conical structure, we have the radius, we have the slant height, and we are interested in finding the cost of painting the curved surface. So basically, we need to calculate the curved surface area of the conical tomb structure, and then once we have calculated the area, we have to calculate the cost of painting that area of the conical structure, given that it costs 210 rupees to paint or whitewash 100 meters square. So the first thing we need to do is we need to compute or calculate the curved surface area. So I'm going to write CSA, curved surface area, and the formula for that is pi RL, which is equal to 22 by 7. R we have obtained as 7 meters, and we have L as 25 meters. So solving this, 7 and 7 will cancel out, so we get 22 into 25 as the curved surface area for the conical structure, which is equal to 550 meters square. Okay, so we have got the curved surface area value for the conical structure now. The next piece of information available with us is the cost of painting 100 meters square. So let's write that. Cost of painting or whitewashing 100 meters square is rupees 210, equals 210 rupees. Okay, I'm not writing the rupees here, it's understood, it's rupees. Okay, so that's for 100 meters square. So if you know the cost of whitewashing for 100 meters square, what is the cost of whitewashing 1 meter square? So that will be 210 divided by 100. Okay, that's going to be 2.1 rupees per meter square. Now that we have obtained the cost of whitewashing for each meter square, we are interested in finding what is the cost of whitewashing 550 meters square. So that will give us cost of whitewashing 550 meter square is the cost per meter square into the curved surface area. Cost per meter square into the curved surface area of the conical tomb. So we now have the cost per meter is 210 divided by 100. That's the cost of painting per meter square for 1 meter square. And we need to multiply that with the total area of the tomb, which is 550 meters square. So solving that should give us the total cost of whitewashing the conical tomb structure. and that works out to be 1155. Okay, so the cost of whitewashing the conical structure is rupees 1155. So that is, it is equal to rupees 1155. Okay, so that's our answer. So we have calculated the cost of painting the conical tomb given these dimensions. Okay, and we were given that the cost to paint 100 meter squares is 210 rupees. So from that we were able to calculate what is the cost of painting or whitewashing 1 meter square, and then we multiplied that cost of 1 meter square with the total with the curved surface area of the conical tomb structure, and we got the total cost of painting the conical structure as rupees 1155. Now let us do the next problem here, which states that there is a joker's cap which is in the form of a right circular cone, and the cone has a base radius of 7 centimeters and a height of 24 centimeters. We are asked to find the area of the sheet required to make 10 such caps. So how can we proceed with this? So given the base radius and the height, we can first find what is the slant height by applying Pythagoras theorem. So we'll get L. Once we have calculated L, we can calculate the curved surface area of one cap. And once we have the curved surface area of one cap, we just need to multiply that answer by 10 to get the curved surface area of 10 such caps, and that will be the area of the sheet required to make 10 such caps. Okay, so again, let's write down first what are the given quantities. So we have been given with R equals 7 centimeters. We are also given the height h to be 24 centimeters, and we can find the slant height from here. So slant height, which is denoted by L, is going to be square root of R square plus h square. So that is going to be square root of 7 square plus 24 square. So 7 square is 49 and 24 square is 576, and I believe that adds up to square root of 625, and that should be 25 centimeters. Okay, so we have found now the slant height of the conical cap to be 25 centimeters. From the slant height of the conical shape, we can now calculate the curved surface area. So we can write the curved surface area, CSA, curved surface area, and the formula for that is pi r L, and we can substitute the values of r and L and pi and get the value for the curved surface area. That will be the area of the sheet required to make one cap. So that's equal to 22 by 7 for pi. That's 22 by 7. The radius r is equal to 7, and the slant height is 25. And from that we get the curved surface area to be equal to 550 centimeters square. So that's the curved surface area of one cap. So we now have the area of the sheet required to make one such cap, and that is the curved surface area of a single cap, which is 550 centimeters square. So we can now calculate the area of the sheet required for 10 such caps. So area of sheet required for 10 caps, that's caps, okay, for 10 caps equals area of one cap into 10. So that will be 10 into, let me erase this, that's equal to 10 into 550. So that will give us 5,500 centimeters square. So the area of the sheet required to make 10 such caps is 5,500 centimeters square. So it's a fairly straightforward problem here also. Okay, so basically when you're given the dimensions of a single cap and we're asked to find how much is the area of the sheet to make multiple such caps, so we'll just find what is the area for a single cap, that is the curved surface area in this case. So once we have got the curved surface area for a single cap, we can then compute the curved surface area for any number of such caps, in this case 10, by multiplying the number of caps with the curved surface area of a single cap. So in this case we have 10 caps, so we multiplied the curved surface area by the number of caps 10, and we obtained the answer as 5500 centimeters squared. Okay, so that's the second problem for today's session. We will now do the last problem for today's session, and again here it's based on the calculation of the curved surface area of a cone. And again, what we are given here is that there's a bus stop that is barricaded from the remaining part of the road using 50 cones made of recycled cardboard. Okay, all this is extra information. What is important for us is there are 50 hollow cones, and the dimensions for each of the cone are given as the base diameter is 40 centimeters and the height of the cone is 1 meter. And we are told that we have to paint the outer side of each of these cones, and the cost of painting is rupees 12 per meter square. And we are asked to find what is the cost of painting all these cones. Okay, so for what we have to do is, first of all, we have to calculate what is the curved surface area of a single cone, and then we know there are 50 such cones, so we will multiply the curved surface area of a single cone with 50 to find the curved surface area of all the 50 cones. So once we know the total area of all the 50, that is the total curved surface area of all the 50 cones, then we just have to multiply with the cost per meter square to get the cost of painting all the cones. So fairly straightforward. Okay, so let us see what is the information given to us again here. So for each of the cones given is the base diameter. Let's write the height first. Okay, height equals 1 meter, and we are given the diameter D to be 40 centimeters. So therefore the radius R will be 40 centimeters by 2, which is going to be 20 centimeters. And we'll convert the centimeter to meter because we have the height also in terms of meters. So 20 centimeters is nothing but 20 by 100 meters, which is simply 0.2 meters. Okay, so we have the height of the cone as well as the radius of the cone in the same units, which is meters now. And since we are interested in finding the curved surface area, because that is the area that is going to be painted on each of the cones, for the curved surface area we need to find the slant height. So to find the slant height, so we use the Pythagoras theorem again. So slant height L is equal to the square root of r square plus h square. So that is equal to r square is 0.2 square plus h is 1 meter, so it's 1 square. So we get the square root of 1.04. Okay, 1.04 under the root, and we have given this value, the square root of 1.04 we have to use as 1.02. Okay, this is the value that's already given in the question to us, so we don't need to calculate or compute the square root of 1.04. That is given to us, so that is 1.02. Okay, so we have got now the slant height of the conical structure that is used for barricading the road. Okay, so that's we now have the dimensions of the cone, and from that we can find the curved surface area. So the curved surface area, which is pi RL. So we are asked to use the value of pi as 3.14, so it's 3.14 The value of R we have already obtained here previously as 0.2 meters. So that will be into 0.2. And the value of L we have already computed here is 1.02 meters into 1.02. So when we multiply these numbers, we get the curved surface area of each of the conical structure. And we get the value for this as 0.64056. Okay, so that's the curved surface area of a single cone. So that is CSA of one cone equals 0.64056. Of course, it's meter square. Okay, so the area is in meter square because the units of our dimensions are all in meters. So the area is in meter square. So now that we have the curved surface area of a single cone, we can now calculate the curved surface area of 50 cones because there are a total of 50 cones used for barricading. So we will calculate the curved surface area of 50 cones is equal to 50 into curved surface area of one cone. So which will be 50 into 0.64056. So that will give the curved surface area of 50 cones, which happens to be 32.028 meter square. Okay, so we have now got the curved surface area for 50 cones. Next, we know the cost of painting per meter square that is given in the question. So cost of painting per meter square is rupees 12. So the cost of painting 32.028 meter squares will be, so therefore cost of painting 32.028 meter square equals, so we just have to multiply the cost per meter square with the total area here, which is 32.028. So that will give us an answer of 384.336. Okay, that's rupees. Okay, so the total cost of painting all the 50 cones is going to be rupees 384.336, given that the cost of painting per meter square is rupees 12. So basically what we have done is we have calculated first of all the cost of the curved surface area of a single cone. So once we have got the curved surface area of a single cone, then we multiplied that with 50 because we are given that the number of cones is 50. So the area of one cone is multiplied with 50 to get the curved surface area of all the 50 cones. And then we multiplied the total area of all the 50 cones with the cost of painting per meter square, which is given as 12. And that product gives us the cost of painting all the 50 cones, which happens to be 384.336 rupees. Okay, so we have completed this exercise, all the major parts of the exercise. There are a couple of problems from exercise 11.1 which I have not solved in my videos. Those are straightforward problems which the students can do by themselves. Okay, and if you are looking for any specific problem from the textbook which you are not able to understand, please do post your questions in the comments, and I will try to explain in a separate video the solution for those questions and post it.